Idaho, I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Hello from Idaho. It's a good day for coffee. It's a little nippy outside. It's kind of early. Anyway, welcome to part 2 of my TIG Torch Cooler. I'm going to start off with putting my pressure gauge in and mounting the fan, then building a bracket for my container, putting the bulkhead fittings in, and then lastly we will put in the pump and plumb it all up, and then we'll do some wiring. Hopefully that all fits in one 30-minute video. If not, there may be a part 3, who knows. So the plan is to have the gauge here in the center. I'll have a hot and cold hose running along here, and this third one in the middle. I'll be able to connect them to this side panel. I'll be able to, the plan has always been to connect this to the side panel. So most of my plumbing will be done by removing this side panel and hooking everything up to it. That's the plan. Let's see how it goes. So this is supposed to be 2.5 inches. 2.43. This is 2.5, right on the money. So that's not a very big lip. And so I'm going to drill 2 3/8 and then sneak up on the diameter so that we have a snug fit. And then I have to make a bracket that is a U-shaped bracket that holds it into the case. Okay, the bonehead photographer that I hired, namely me, forgot to press record while I was finishing up my pressure gauge mount. So, but suffice to say that we drilled a hole, we sanded it to size, and then I made a bracket that will hold it in there. And so now we're done with the front panel, and we're on to other things. Okay, we're going to make some holes for the bulkhead fittings and hope I don't crack this jug. Okay, we are beginning to see what we already knew from the CAD drawing. The pump fits underneath the fans in this corner. The hose will go from here, a little service loop, and go into the pump, which is a couple of inches lower. this line can go underneath the fan in a little loop and come out here and go into the cooler. From the back side of the cooler to the top fitting is a straight line, and then from the bottom fitting, the hose will come right here behind the container out in a service loop and go into the fitting. But we knew all that from the CAD system. We knew it was all going to fit, and it's nice to have confirmation, but I thought I'd show you on the actual machine. Okay, today seems to be my day for screw-ups. Anyway, I used my little saw and cut out a piece of aluminum sheet for my container bracket, and I've already bent one angle over the edge of my welding table. I'm about to bend the other angle. Well, it's a crude technique if you don't have a finger brake, but it worked for lots of years before finger brakes were invented. It still works. So it looks like we have a container we have a container bracket. Okay. Now there's some more pieces. There's let's see, this side here. So over here there's another piece like this, and then some corner brackets, and then I need to weld this piece of rod in the corner for the hinge, but we're getting there. Okay, time for the third coat on my container for the reservoir, my little bracket, my little hinge bracket. I think I've lost a bunch of recording today because I just noticed that sometimes when I press the go button, camera reverts back to photo. So when I get this downloaded, I expect to be disappointed. Okay, last coat. Okay, because of lost footage, I feel compelled to get caught up. So here is the bracket that I made to mount my pressure gauge. It's held on by the fitting, and so it just captures the pressure gauge in the front of the chassis. And then here's the reservoir bracket. I call it a bracket. It's got these little ears that stick out for the hinges, like so. There's two of those, and then it will tilt. And so I need to round up some more screws, and then I can put that in. My reservoir fits in it really well. So that's kind of the lost footage that that was probably all my fault. And I apologize for that, but progress is being made. Next, we're going to put in the pump. Okay, the bracket for the reservoir is in. So I've cut a little service loop for the pump, and it will sit like this. The hose isn't pushed all the way on, but this is basically where I'm going to drill my holes. Okay, now we have a pump mounted in there. So far, so good. So I want a T-fitting that will mount to the side of my case. And you can buy fittings with tabs on them. But one bad thing about working out of a junk box of fittings is that you don't usually have everything perfect. So this is going to be my solution. I've got a standard quarter NPT fitting here and a piece of brass. I've applied some flux and 2 little strips of silver solder. So we're going to solder this T down to this piece of brass and make a bracket. And while you can just heat it up and feed the solder in, with some things I just like to cut it to length and then heat it. So that's what we're going to do. We need to get up to about 450 degrees, which I can do easily with my map torch. So here goes. Okay, the solder is beginning to melt on this side. All right, we have a good fillet there. And the solder just melted on that side with a good fillet. And that's all there is to it. I keep a few fire brick around in the shop. Not that my welding table won't handle it, but this doesn't soak up the heat like a piece of metal or a piece of aluminum underneath of it. So you actually get quicker results. So when this cools and I clean up the flux residue, it will be mounted on the bulkhead and help control my tubing. Okay, we got the flux cleaned off a little bit. We got nice little fillets of silver solder in the joint. That's a good part. Okay, a little more progress. The front panel is done. Inside, we're making a bit of progress as well. I've got the quick disconnects converted from 5/16 to 3/8. And then I've got my T in there, which tees off pressure to the cold quick disconnect and the back of the pressure gauge. And just like in the CAD drawings, it clears the top of the coolant reservoir. I'm getting pretty excited at this point. Okay, it's time to do a little wiring and plumbing. I've drilled a hole in the back here, put in a grommet, run my power cord through there, getting ready to hook it up to the switch. I need to extend these two wires so they can connect to the power supply, which will go here. And I need to extend the wires on the pump. And if you're a lifelong fabricator and electrical engineer, you probably have boxes like this. This is my wiring box. And if you dig in there deep enough, most projects can be finished out of that box. And how do you end up with a box like this, you say? Well, yard sales, people cleaning out their garage, people giving away stuff, remnants from a project. You need 10 feet of speaker wire, but you can only buy 50, blah, 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 things like that. The other good place to find things is when they close stores. Idaho used to have a store called Ernst. Other hardware places have closed. D&B downsized their hardware department. So did Fred Meyer's. And so whenever I find stuff on a super deal, I find stuff at yard sales, whatever, I just buy it and save it for later. Some of it's pretty special. You know, you got multi-conductor, waterproof, weatherproof conductings. Some of it's just regular wire. And whenever I throw away a tool or an appliance, I always cut the cord off of it and save it for a project. And in this case, I have a cord with the end cut off that I'm just gonna cut a few inches off of it to wire between the switch and the power supply. Here's a computer cord that will allow me to plug my water cooler into a 110 volt outlet. So this outlet here will plug into the end that's on the cooler, which plugs into my welder. So to do a test, I'm going to set my power supply to 110, use this little jumper cable, fill it up, and test the pressure, block the line and get full pressure, test for leaks, that sort of thing. Anyway, out of my junk box, I also have another box full of wire ties, and so I got a bunch of wire ties here that allow you to bolt it down. I've got some general small wire ties, and then I've got some 20 gauge red and black, which I'll use to extend the fan wiring and use to wire up my LED. And I've got some 16 gauge red and black for the pump. So that's my supplies for this next step. One of the first things I need to do for my wiring is to get a good chassis ground. So you don't want to depend on the bolt touching the hole. So I've made a little thing to make this easier. I started out with a bit of a spade bit, look like this. It's got the center point, and then it has two cutters on the edge. And what I did was to turn that into a flat shouldered bit. So I still have my center point, and then these two flat cutters. And so I drill a pilot hole and then put this in there, and these flat cutting edges will scrape away all the paint. And so I've got a nice looking place to put my ground lug, and I don't have to scratch it with a screwdriver or try to sand the paint off or whatever. And so this works pretty good for me. So to use this hole right here for my green wire ground, since it's already handy. I'll take my special paint cutting bit. I painted it red so it's easy to find in my drill bit drawer, but we just gently take off the paint. Just like that. Try to take off as little metal as possible, but you get the idea. Okay, now you can see we've got a nice clean spot for a green wire ground in 2 places. Okay, I'm back from Home Depot. Had to get a new switch, and while I was gone I decided that showing you every wiring connection and connector was going to be pretty boring, so I just went ahead and wired it up, and I'll spend a little time telling you what I did. So the power supply sits on the top, as in the original CAD drawing. Power comes in from the back, goes up to the switch, and then from the switch it goes to the power supply line, neutral, and green wire ground. I dressed the wires for the fans along this route as well, and then there's another bolt type wire tie here. I extended the wires on the pump, and they run up through another wire tie here underneath the plumbing and up to the 12 volts as well. This wire goes up to the LED to indicate that it's on, and that's really all there is for wiring. So when you turn it on, there's a little delay, and then the LED comes on. You can see the fans are moving, and the pump is making a hell of a noise because it's just running open loop. But if I plug that up, this is how noisy it's going to be when it runs. And so I've got 3 more water connections to make, and then we can test it for real. Okay, I spent another 30 minutes plumbing up this thing, and so we have all of the tubing in. About the only thing really left to do is to fill it up and see if it squirts water all the way across the garage. So we've got exit from the tank, inlet to the pump. The pump pumps this way, outlet from the pump, into the radiator, out of the radiator, into the T, out of the T, into the pressure gauge and the top quick connect fitting, which is cold. It comes back on the red, which goes back into the top of the reservoir. I suppose now is as good as any time to talk about some of the design choices I made and some of the design choices I didn't make. If y'all are going to do this, I would recommend a clear coolant container. It solves a lot of problems. You don't need a flow indicator. You don't need a level gauge. And most of the tanks that I've seen welded up have been out of aluminum, And of course, that's a mixed metal thing, which you don't want to do. So I would recommend a clear plastic reservoir. The Procon pump out of soda bottling equipment is one of the most popular, but it is very expensive, like $160 used, even more new. And it produces in excess of 100 psi, which means that you have to throttle it back in some way. These diaphragm pumps flow just exactly the right amount of fluid. They're 1.2 to 1.5 gallons per hour. They have about a 50 psi. Some of them have an 80 psi maximum. This one actually has a cutoff switch on it. And so I would much prefer this pump. In the blurbage, it says this pump should only be run for periods up to 6 hours, which sounds like a continuous duty pump to me. For this application, I certainly don't weld for 6 hours in a row. And one of the other advantages is that the water flowing into this is cooled, and so that helps keep the pump cool. The little PC gaming radiator is a pretty good way to go. They make one that is 3 bays, takes 3 fans. And that kind of brings me to my next point. If I had to do this over again, I would choose a bigger enclosure. This one works fine, but it gets pretty busy at the end when you get everything in it. And it didn't leave me room for a 3-bay radiator, which I don't think I need, but it would have been a nice option. If money were no object, I would have opted for those push connect fittings. I got like 14 hose clamps in here, and they're not that nice to look at, but they certainly do a good job. But the push to connects will be a lot nicer, and but they're pretty expensive, and I didn't have any in my junk box, and so $5 a fitting or something like that, you end up with $40 or $50 worth of fittings. So even with the plumbing in, my tank tilts out for filling and back in for use. And there's the front. Now I'm going to test it. So we're going to pour our coolant in. We should have plenty of space since that's a 2-gallon container. And I only have 1 gallon of coolant right now. Guess I better put the rest of it in. It looks like it's water or distilled water, but it's actually coolant made specifically for TIG torches. It's Cantesco welding chemical products. They make some that are colored, and while that might give a better visual, I don't think it really adds much value. They make them they make the coolant, TIG welder coolant, in a couple of flavors. One of them is not good for shops that get down below freezing, and the other one takes the temperature that can withstand down a little bit below freezing, but not a lot. Okay, once again I got the power supply set on 125, and I'm powering this from the wall and not my welder. And I think if I turn it on now, the fact that I don't have any lines plugged here will mean that it will it won't pump anything, that water won't come out here. If that's incorrect, I'm probably going to make a pretty big mess. But I thought we would try it anyway. So here goes. Well, I already have a leak. After a little of inspection, it seems like the radiator is actually leaking. It's not leaking out of the fittings, but it's dripping out of the bottom of the radiator. So I possibly got a defective radiator. I'm going to have to dig into this a little bit farther. Okay, I took the fans off of the radiator, and now I can see where it's leaking. It's leaking right in here, kind of on the second, where the second fan would go, right below, right in this area. So I'm going to have to get a replacement radiator, and so we're on hold for a while. Okay, here we are again. On video, I know it seemed like it just happened like that, but this is several weeks down the road from when I discovered my leak. And it's been quite an adventure. Let me explain a little bit. So I did indeed have a leak in my radiator. I took it off, took some photos, sent it back, and they advised that it had been punctured by one of the mounting screws. Well, I was eventually able to convince them that it wasn't me that punctured it, and I showed them my mounting screws, which are like 1/4 of an inch. I cut them 2 lengths, as you've seen me do before. And so they eventually agreed to send me another radiator. Well, then we had to wait on one to appear, and I finally got the radiator and got it replumbed back in and did another test. And now I don't have the big gushing leak, but I did have a drip. So I did a little troubleshooting and found out where the drip was. And it was in this fitting right here. This is the pressure side that tees off to the pressure gauge and then goes out to the TIG torch. This fitting that converts from 5/16 to 3/8. Right there on the 3/8 side, it would always drip. And I put 2 hose clamps on it. I eventually realized, but it took me a while because it kind of goes against my paradigm, that the fitting was actually bad. And not just a defective fitting, they are all manufactured bad. The end that goes into 5/16 is fine. The end that goes into the 3/8 is actually a 32nd of an inch undersized, and instead of having hose barbs, it's kind of got these little bumps. And so here's a good fitting, and you can see that the difference in size. And anyway, this one doesn't leak. Several of these that I tried do leak. So now I have no leaks. The whole system right now is under 60 psi of pressure because I've got no hoses hooked to it. So when I turn the pump on, it just pumps up to pressure and stays there. During the course of doing this, I thought maybe it was the hose. And so I bought better hose. This hose is nylon reinforced and it doesn't kink when you bend it. And as I'll insert a picture right here. You can see one place where on a tight band it was kinked. But even after I replaced the hose with these defective fittings, I still had a leak. And so I eventually went and ordered a couple more fittings off of McMaster Carr. These are chemical safe, and sure enough, that fixes my problem. So I had a long time of troubleshooting for a $2 part. Nonetheless, we finally got it to not leak, and I've got this turned around this way to show you the fitting, but also to show you that it is really nice to have both sides of my container come off for troubleshooting and repair. And so the next steps is to bolt this down to the side, bolt my T down to the side, get my bolt to go through my wire tie, and then put that side back on, and then install it in my welder. I've actually got a piece of air hose in the way here, but it goes in this slot, and I've got to hook these cooling lines up to it, and then we'll actually be able to test the welder and the cooler at the same time. The other thing I've got here is another gallon of coolant. I've eventually leaked most of a gallon of coolant all on the floor, which you can see I got my floor dry down here. Still needs to be vacuumed up. And then the other thing I have here is a cable. It's actually a power cord. And you say, why do you have that there? Well, my neighbor across the street was throwing away a vacuum cleaner. And just before the garbage truck come, I went over there and cut. It's got like a nice 25-foot, 110-volt, two-prong cable on it. And this goes back to what I was telling you of how you end up building projects cheaply, is to keep things around that most people would throw away. So I'm going to put this all back together, put it in there, and then we'll see it work with the welder on. Okay, moment of truth. The cooler is in the welding cart and is turned so we can see inside of it. And as you can tell, I'm set to TIG welding, in this case 15 amps. And when I turn on the cooler, we ought to get cooler action. Okay, so we have about 50 psi. If I get straight onto it, it's about 50 psi. We got our blue LED light to tell us that it's on. We got cold water running to the TIG torch and returning on the red. And because we have a clear side, we can see flow, water level, and this puppy dog is done. It's been sitting in my shop now for 5 days under pressure, and it's held that pressure. I got no lips, no drips, no leaks, and so I'm very happy with it. It turned out to be everything that I had hoped. When I push it back in there and square it up, it'll look very much like a professional commercial unit. Okay, here we go. We are done. It's taken a little while. I had one defective part. Actually had one defective radiator and 4 defective fittings, but we worked through that and it's done. It's a little louder than I'd like, and I've got that pump mounted directly to the side of the unit on rubber feet, and I may play around with different polymers for that isolation, but it's going to work. And the welder itself is pretty loud, so it's not like it was going to be perfectly quiet in here anyway. So I hope this helps somebody build their own TIG Torch Cooler, and goodbye from Idaho. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments, and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.